Okay, so today we're picking up on solving a quadratic application using inequalities. You should probably write down in your note page over the word or next to the word quadratic inequality, the words sign chart. Because when we do quadratic inequalities, we use a sign chart to help us figure out where are the positive numbers, where are the negative numbers, where are the zeros. Okay? And have your red and black pen like uncapped and ready to go. And of course you can leave your cap on your highlighter. Your job is to highlight the keywords when you hear me read them. And your other job is to try to define the variable. What are we looking for? Here we go. Profit and loss analysis. At a price of P dollars per unit, the marketing department in a company estimates that the weekly cost, C, and the revenue, R, in thousands of dollars can be given by the equations C equals 45 minus 5P and R equals 9P minus P squared. Find the prices for which the company has A, profit, B, a loss. So the keywords there are not the typical keywords that we see, and on top of that, they're not on our paper. So let's use our brains. What's a profit mean? Greater than, right? Would you agree? Yeah. So why would we flip to the other side of our note page real quick, and under the greater than column, write the word profit. And of course, our other keyword is the word loss, and that would be representing less than. So if you could add those two words to our, that would be good. Okay, so I'm going to pick up my black pen now. And I'm going to come back up here and I'm going to start defining some things. So I'm going to start with the revenue. Revenue, because if I don't know what that means, this is really a difficult problem to solve, and it doesn't need to be. Revenue, notice I picked up my black pen, is the money that is coming in. Jake, can you do me a favor and close the door real quick? Thank you. It's the money that I make if I own a company and I'm selling a product. My revenue is the money coming in. I'm switching pens to my red pen now. My cost is my money. If it's not going out, if it's not coming in, it's, I just told you, going out. Okay. So now I'm color coding things. If I'm making money, it's in the black. If I'm losing money or spending money, it's in the red. We actually call it that in business. If you're operating in the black, it means you're making a profit. If you're operating in the red, it means you're losing money. Okay? Even on a battery, a car battery, right? Black is positive, red is negative. Makes sense. Okay, so if I'm making a profit, then my revenue, black pen again, is greater than, right, my cost. I'm switching to my red pen for my C. My revenue is greater than my cost. More money in than money out. Switching back to my black pen again, a loss is when my revenue is less than, switching to red, my cost. So you can see my two inequalities there. Thankfully, I don't have to solve this problem twice to get that. In my profit, what kind of numbers will I be looking for? Positives or negatives? So let's pick up our black pen and write the words positive. We are looking for positive numbers. If we're looking for a loss, we are looking for negative numbers. P.S. For your information, if you color code your homework, 10 points extra credit. It's a 28-point assignment. You could get up to 38 points. Yes, you can. Color coding is important for your math brain. When you organize your math in colors, you are really doing some extra learning and working at a higher analytical level. So color code, it's good for your brain. Okay, so let's define our variable. We are supposed to find the prices per unit. So what will I set my price at? So I'm going to pick up my pencil now and define my variable. I'm going to let P, because it told me to use P, and it's P in my equations here, represent the price per unit. So let's say I'm selling apps. I developed some fun little app like something really fun. Something so fun you'll pay some money for it. Like you don't want a free app, you gotta have it. It's like Game of Thrones, awesome. It's Stranger Things, awesome. There we go. Now we're talking. Okay. So, I know that if my cost equals my revenue, exactly, I'm going to break even. You remember we called that a break point. So in order to solve this problem, I'm going to find my break point, plural. So I'm going to write this down. My little notes. Break point is when my revenue equals my cost, meaning I don't make any money, I don't lose any money, I make absolutely $0. Because it's important for me to find my zeros. If I want to find where are the positive numbers and where are the negatives, I have to know where my zeros live. So this is the problem I'm going to solve. I'm going to set my revenue equal to my cost. Okay? And then I'm going to use that information, those zeros, to help me make my sign chart. Are you ready? So I'm going to my black pen because I'm about to write my revenue down. That's my money coming in. So my revenue, if you don't mind, I'm going to rearrange it so that my A term is first. I'm going to say negative P squared plus 9P is equal to, oh, I switching to my pencil there for a second. And then I'm switching to my cost, so I'm switching to red. And I am rearranging this as well. Negative 5P plus 45. Okay. So if I set them equal to each other, I'm going to find out where I break even, right? Where my price per unit yields $0, zero, nothing. Let's find that price point. So to do that, I'm picking up my pencil again. I'm going to make it equal 0. I am going to make this point, and I would like you to write it down. Do not move your A term. When you're doing inequalities, don't move your A term because it dictates what kind of quadratic, what kind of parabola you're going to graph. When your A term, like this right here, your A term's -1, then your parabola will max out. It'll be flipped upside down. If you move the A term to this side, you're going to take your answer and you're going to find the exact wrong answer instead of the exact right answer. So don't move your A term. It is stuck where it is. So to do this, I'm going to take and put the 5p over here by adding it. So plus 5p. I'm also going to subtract 45 and cancel that out. So I get negative p squared plus 14p minus 45 equals 0. And I didn't move my p term and change it to a positive, my a term. I didn't change my a term because I don't want to flip my parabola. Okay, so we're going to have to factor that. And I'm going to use AC method because my a is not 1, it's negative 1. So have to be careful. So I'm going to multiply my a times c. Negative 1 times negative 45 is 45. And my b term is 14. So I'm looking for two numbers that multiply to 45 and add to 14. I say 9 and 5. I'm going to circle them. And then I'm going to break up my b term with those two numbers. So negative p squared plus 9, I'm going to circle it, p plus 5, come on, p minus 45 equals 0. Maybe I'll just highlight them. There we go. Okay. Now I'm going to factor the front and the factor the back by cutting it in half and factoring by grouping. So in the front, I'm going to factor out a negative p. And that leaves me with p minus 9. Because negative p times p is negative p squared. Negative p times negative 9, positive 9p. In the back, I'm going to factor out a positive 5, which also leaves me with p minus 9 equals 0. And I'm going to scoot the page up a little bit for the people in the back. You're welcome. I don't want to move that. Okay, here we go. So we get p minus 9 times negative p plus 5 equals 0. And we're almost done finding our zeros, or our breakpoints. P minus 9 equals 0. Negative p plus 5 equals 0. And we solve. P equals 9, because we add 9. Or negative p equals negative 5, because we subtract 5. And then we're going to divide by negative 1 to get the p isolated. P equals 5. If negative p equals negative 5, then positive p equals positive 5. That's how that works. So people, these are my prices per unit. So I'm going to write myself a little note. The breakpoint prices are $5 and $9. Meaning, if I charge you $5 for my app, I make no money. If I charge you $9 for my app, I make no money. I don't lose it either, but that's not very good business. Okay, question? We're going to find out right now. We are going to find out. Okay, so these are my zeros. That's what they are. So I'm going to take my two quantities over to here, and I'm going to make my sign chart. P minus 9, negative p plus 5, and I'm going to put my zeros in. They are 5 and 9. And then I'm going to see real quick if it'll let me just grab this little part right here. Oh, it won't. So remember that we wanted positive here, and we wanted negative for our loss. So this is our profit was positive, and our loss was negative. Okay, did we ever want our zeros? No. So what I'm going to do is I'm going to put my parentheses on my zeros because I don't want them. If I'm making a profit, I'm making money. If I'm losing money, I'm losing money. If I'm breaking even, that's not a profit or a loss. That's breaking even. Okay, so let's put our zeros in. For our top binomial, our 0 is 9. For our bottom binomial, our 0 is 5. Okay, so I'm going to separate my 3 intervals, and I'm going to pick up my red pen because color coding. So I'm going to find all my negative intervals for p minus 9. Since my p is positive, my negatives are to which side of the 0? Left. Okay, so I got those in. Don't put it down. Let's go to the bottom. We have a negative p. So what does that do to our placement of our negative? It switches to the right of 0, correct? All right, now I'm going to go get my black pen, and I'm going to put my positives in the empty spaces. And I'm going to go ahead and keep my black pen, and I'm going to figure out which of these intervals is actually a positive interval. Which interval, 1, 2, or 3? 2. So this is our profit interval between 5 and 9. So John, you asked a really good question. What do you think the maximum profit? What's the price point if I want to maximize my profit? It's a parabola. 7. Watch, I'll show you. Okay, so picking up your red pen, your first interval is, which makes it a loss. So if I charge you under $5, I'm losing money, probably because it costs more to make than it does to sell. And if I charge over $9, I'm making a loss, probably because nobody wants to buy it. It's not worth more than $9 to them. Okay, so then I would go and I would answer the question in complete sentences. So I'm going to erase if you all have this written down. Yes? Yes. Okay, so I'm going to pick up my black pen and I'm going to answer A. And I'm going to use my sentence structure, okay, to help me. The company will profit if the price per unit is between, yes, $5 and, intersection, $9. There's an intersection. See the word and? There it is. So that's my answer for A. B, switching to red because it's my loss. Starting with the same sentence structure, the company, I'm getting lazy, so I'm going to write co, will lose money if the price per unit, I'm going to go PPP for price per unit. Oh, PPU, sorry. You guys okay with that? PPU is actually an acronym for price per unit. Is less than 5 or union, there's a word or, more than $9. So we used our breakpoint and our sign chart to help us develop that solution. Your job now is to do number 1 on your assignment. Okay, through the process again, I'm going to read it. You are looking for the keywords that tell you what kind of inequality we're going to choose, and also you're going to try to define the variable. So come along with me. Haven't coughed all day. Why do I always cough when I'm when I'm videoing, recording. Here we go. When successful new software is first introduced, keyword there, successful software, the weekly sales generally increase rapidly for a period of time and then begin to decrease, not decrease, but decrease. Suppose that weekly sales, S, in thousands of units, important details, T weeks after the software is introduced with a D, not an S, are given by the equation sales equals 130 times weeks, however many weeks, divided by however many weeks squared plus 100. When will the sales be 6,000 units per week or more? Keywords. Anybody have an idea? Per week or more. So if it was 6,000 units per week, that would be equals. And more would be greater than. So what we're saying is that our sales will be greater than or equal to, be careful, the word here, or the number I'm looking for, is not 6,000, but 6. Why? Because S is in thousands. So I would highlight this as important to pay attention to. There was a reason that was put into the instructions. So what I'm going to do is I'm going to highlight that my S is 6. How many thousands? 6 of them. So you divide 6,000 by 1,000 and it'll tell you it wants 6. Okay, so we've determined that we want the sales to be greater than or equal to 6,000. What is our variable? What are we looking for? Keyword there is time. And our time up here is being measured in weeks. So we are going to let T, because our equation already has the variable in it, equal the time in weeks. So we definitely needed to define that. Okay, let's get going. So we know that we are looking for greater than or equal to 6,000, and our time is in weeks. So we were given this formula. So I can replace my sales with the actual sales in terms of time. So I'm going to write this equation as 130t over t squared plus 100 is greater than or equal to 6. Really should be doing this in my pencil. I'm switching to my pencil. Okay. I didn't really want any of that to be in red. All I did was I replaced the sales with what the sales was equal to so that I can solve for t, because that's what I want. I want to know what's my time. I already know what I want my sales to be. I need to know how many weeks. At what weeks will I be selling 6,000 units or more? Okay, so to solve this, we recognize this, right? We're going to make it greater than or equal to 0. So the first thing we're going to do is subtract 6 and put it on the other side. So we get 130t over t squared plus 100 minus 6, I'm going to put that over 1 if you don't mind, is greater than or equal to 0. And then I'm going to stop and make a decision. What am I looking for? What kind of numbers if I'm greater than or equal to 0? positive, and 0. So I'm going to highlight that. It says my focus is that's what I'm looking for. When are my sales above or equal to 6,000? Okay, so I'm just going to keep switching pages so I can keep all my math up at the top of the page so people in the back can see. Are you ready to move on? Yeah. Okay, so we have the equation 130t over t squared plus 100 minus 6 over 1. And I'm going to switch to a blue pen here because I want to subtract those, but I cannot because they don't have a common denominator. So I need to make them have a common denominator by multiplying this one times 1, which won't change it, and this one times t squared plus 100 over t squared plus 100. That still equals 1, by the way, right? Because if something is divided by itself, it's 1. Okay? And at this point, I'm looking for my zeros, so I don't need my greater than or equal to anymore. I'll just go with my equation. And I'm going to distribute, so now I can subtract. Because I have the same denominator now, so I can subtract. So I get 130t minus 6t squared through my distribution of negative 6 times t squared. And then I'm going to do negative 6 times 100, so negative 100 all over t squared plus 100. All right, so I subtracted them. They're subtracted. Equals 0. That's a 600. Thank you. Thank you. It's a 600. I appreciate that. Thank you. We don't need that mistake. This problem's complicated enough. Okay, so now I need to find my numerator zeros. So I'm going to start with notes for my numerator zeros. To find them, I'm first going to carefully reorder it so that I'm writing it in descending order of exponents. So the negative 6t squared comes first, and then the positive 130t, and then the negative 600. So descending order is really important if I'm going to factor. Notice I didn't change the signs of any of my terms. I just reordered them. Now I'm going to use my AC chart. And here's what I don't want to do. I do not, because I'm working with an inequality as my overall goal, I don't want to factor out my negative a because that keeps my parabola maxed out. You don't want to minimize it or I'm going to change the answer. So I'm not even going to factor out a 2, even though I could, or maybe, yeah, a 2. I'm not going to, because I can see the answer to this. A times C is 3,600, positive 3,600. When numbers end in zeros, I like it. And then my B term is 130. I'm not afraid to factor this because the numbers end in zeros, so you know what I do? I ignore them. I look at numbers that multiply to 36 and add to 13. I ignore the zeros. And I think 9 and 4 would fulfill that. Now I'm just going to put my zeros back in because I need 2 zeros. So I'm going to do 90 and 40. And I think that'll fulfill my criteria. 90 times 40 is 3,600. 90 plus 40, 130. So there it is. So I'm going to highlight those. Boom, boom. You didn't know you could do that? Oh, we learned something new in school today. Like it. Okay, so now I'm going to take and rewrite negative 6t squared plus 90t, and I'm going to circle my, no, I'm highlighting my 90. I'll highlight it in a second. Plus 40t. Make sure your t's have tails on them so they don't look like plus signs. Monkey tails. Remember, did you guys have to learn to write with monkey tails? Oh, man, I did. When I was a little kid, put a monkey tail on it, Christy. Okay. Shh. You know, when you're learning to write in kindergarten, they'll make it fun. Put a monkey tail on it. Okay. We're going to cut it in half. Come on, don't get me distracted. I'm making a video. Here we go. So I'm going to factor the front, and now I can factor out the negative, and 6 will go into both of them, and they both have a t. So I'm going to factor out a negative 6t, leaving me with t minus 15, because negative 6t times negative 15 is positive 90t, so that works out good. And then over here, I'm going to factor out a 40, as I already did this problem, so I know that's correct. And that's also t minus 15, because 40 times 15 is negative 15 is negative 600, equals 0. So my common binomial factor is t minus 15, and my other binomial factor is negative 6t plus 40, equals 0. I'm almost done with my numerator zeros. So I'm going to set t minus 15 equal to 0, and negative 6t plus 40 equal to 0. And I'm going to be a good student and be careful. T equals 15, because I'm adding 15, or negative 6t equals negative 40, because I'm subtracting 40, yes. And then, of course, I need to isolate that t, so I'm going to divide by negative 6, and I get t equals, negative divided by negative is positive, 20 thirds. Now, t is representing time in weeks, if you recall, and I don't measure my weeks in 20 thirds weeks. So I'm going to change that to a fraction of 6 and 2 thirds. So my weeks that create 0, that create exactly 6,000 units, are 15 and 6 and 2 thirds. So these are my 2 zeros for my numerator. Now, I'm getting ready to switch to my denominator zeros. And this is going to be new for you guys. This is something new. My denominator is t squared plus 100. And folks, I can't factor that, because it's not the difference of perfect squares. It's not a special case. It's the sum of perfect squares. So I have two choices. I can use the square root property, which would be my choice, because I don't have a b term. I have my a term and I have my c term. So I square root property. Or I can use a quadratic formula. I'm going to square root property by subtracting 100 and getting t squared equals negative 100. And I am on high alert right now, because I'm about to square root a negative. So when I square root t squared, that gets rid of the squared. And I don't ever forget that I'm doing the positive and negative version of the square root of negative 100. That's not real. There's not a real number that will fit that. So my answer here is t is equal to a positive and a negative, 10 imaginary. It doesn't exist. This means that there are no zeros in my denominator. There are none. There are none. And actually, I don't even know how, there's no zeros. I don't even know how there would be any negatives. Because if I think about this for a minute, can I have less than 0 weeks in time? So the least amount of weeks I can have is 0. And 0 squared plus 100 is positive 100. It doesn't matter what number I square. I could even square negative 5 weeks, which makes no sense at all. But that's still positive 125. So my denominator is not going to produce any negative or 0 response. It's always going to be positive. Okay? Now I'm going to my sign chart. Here we go. So I'm going to take my two numerators, t minus 15 and negative 6t plus 40, and my denominator, because I'm still dividing by this positive number on the bottom, whatever it is. I'm still dividing by it, so I need it. Or maybe I don't. But we're going to be precise. And my zeros are 6 2/3 and 15. And I'm going to ask you the question, do I want my zeros to be part of my solution? Look at our highlighted answer. Yes. So I'm using brackets on my zeros because I want them in my answer. Okay, now I'm going to go and plot my zeros. So my top zero is 15. My other zero is 6 2/3. And then my denominator doesn't have any zeros. So I only have these two sets of zeros here. And now what I'm going to do is I'm pick up my black pen so I can find my positive sections. So switching, since my t in my first term is positive, my positive numbers will be to the right of 0. Do you agree? And then since my t is negative in the next set of terms, my positive will be to the left. And since my denominator was always positive, I'm just going to put a bunch of positives down because it doesn't matter what t is. It's always positive when I square it. Then I'm going to switch to my red pen and fill in all the empty spaces with my negatives. Because by now, I'm just cruising with my sign chart. Since I'm in red pens, I'm going to start with my negative intervals. My first interval is negative, which means it's below 6,000. And also my third interval is also negative, which is also below 6,000. That doesn't say BW, that says below. And then with my black pen, my center is negative times negative divided by positive is positive. So this is where it is above 6,000. And now that I have my sign chart and I have identified all the different intervals, I'm going to highlight the answer I wanted, which was here, when my sales were above, positive. So I'm going to answer my solution, or I'm going to answer the question by going back to the sentence structure in the problem for a moment. Let me go back and look at it. It says, when will sales be 6,000 units per week or more? So I'm going to start by saying sales will be 6,000 or more from, and I'm using the word from to include 6 2/3 weeks to 15 weeks. And the reason I'm using the words from and to is because I want to actually include those numbers. So I don't want to say between them. I want to say from this one to that one, all of it. Now I want to show you a graph, if you don't mind. I want to show you this graph. So let me see if I can find it here. There's your pictures. You're so cute. Okay. Okay, so here I have the graph of this equation. You see I have it highlighted here in red, where my x-axis is representing my time in weeks, and my y-axis is representing my sales in thousands. So if I highlight my sales in thousands right here at 6,000 sales, notice between 6 2/3 and 15, my sales are 6,000. Here at 10, my sales are at 6,500. And also notice the rapid rise and then the slower decrease. This is how software typically sells. If it's successful, it will sell that way. So hopefully that helped you to understand visually a little better what your sign chart was about. Your homework, of course, is to finish that assignment. Here is my instructions for that. Do homework for no more than 45 minutes.